So now we're going to talk about synthetic division. I like synthetic division. It's, quick. It doesn't take a lot of paper. It's very procedural. Now, if you want to know why this works, they give you an example in the book. I'm just going to show you the procedure. But it was interesting this week. I was talking to two women, and they said, "Oh, what do you teach?" And I said, "Math," and they both groaned. But then later, the one said, "Oh, do you teach algebra?" I remember synthetic division. She was talking about that. I was kind of surprised that that was what she remembered. But it's very useful to us later on. So we're going to go through the process. And it takes a few of these before you're going to get the hang of it. We have 4 examples. This one in this video, and then 3 more. But hopefully by the last one, you'll be like, getting it on your own. Okay? So maybe on this first one, just kind of watch the procedure. That might be helpful to you. All right. So you see that we have the dividend here and the divisor. Now, here's the bad news on synthetic division after I said all those nice things. It only works if you have a linear divisor. So you have to have like x plus or minus something. You can't have x squared as the divisor. Okay, then you're going to have to go to long division. But if you have a linear divisor, then you can use synthetic division. So it doesn't have to do with it being a binomial necessarily. It has to be degree 1. The divisor has to be first degree. Okay. So what we do is we think about what would make that divisor 0. And that would be -2. So you're kind of thinking x plus 2, when does that equal 0? At -2. -2 goes in the box, I say. So I put a little box around it. That's what I'm going to be dividing by, -2. That's how I'm going to use the synthetic division. It's really polynomial division. It's just a shorthand. It's a shortcut. Then you're going to take all the coefficients off your original polynomial. Now you have to make sure your polynomial is in order from highest degree to lowest. And you have to make sure there aren't any missing terms. We'll talk about that later. But what I mean by that is 3, 2, 1, 0. Okay, so they're all present and accounted for. So I pull off those coefficients. 2, -3, 4, 5. You want to space them out just a little bit so it doesn't look like 45. And then leave a little space and draw a line. Okay? That is the setup, and that's half the battle, setting it up. So again, you get this number from the divisor, and then you pull off the coefficients on the dividend. Okay. So it shortens things up because we don't have to write out all the x terms. All right. Now we're going to start the synthetic division. The first term always comes straight down. Okay? 2. Then you multiply that by the box. So 2 times -2, and you get -4. So it scoots over a column. All right? So a lot of books will show it with these dotted lines. Sometimes it's helpful, sometimes it's more confusing. But that's what we're doing. The first number always comes straight down, 2. And then you're going to multiply that times the box and put it in the next column. Then you're going to add -3 and -4. That's -7. And then you keep doing this procedure. You're going to take -7 times -2, which is 14. And then you're going to add 18. Then you're going to take 18 times the -2. You always go back to the box. 18 times -2, which is -36. And add, you get -31. Now I always put a box around that because that is going to be my remainder. It might be 0. This time it's not. But that's going to be my remainder. Okay, so that is the kind of synthetic division part. And I don't know why they call it synthetic division, but that's what it's called. Well, what do all those numbers mean? What is the answer? Well, this is going to be the quotient and remainder. Now, it doesn't look like a polynomial, so we have to convert it back to a polynomial. So notice that we started with x cubed. because we're dividing by a linear factor, it's always going to go down 1 degree. So now I'm going to have 2x squared, and then the rest will follow in order. Minus 7x plus 18. So hopefully you can see these exponents going 2, and then 1, and then 0 on x, right? 0 on x. And then, or you can just think of it as the constant. So that's going to be the quotient. And then we also have the remainder. So I'm going to put minus, oops, I'd rather have it be the same color, minus, and I'm going to write it as 31 over the divisor. The divisor was x plus 2. And I would put that as my answer. Now, that minus sign, that's what I was talking about in the last video. You could put plus a negative 31 over x plus 2. I would just write it the way I have it here, but either way is fine. Okay, so that's one example of synthetic division, and we get more examples.